Let's start with the simple examples. Imagine two students, student A and student B. The student A memorizes every example from a textbook, and while student B actually understands the logic and applies it to a new problems. Now guess what? We have just met instant-based learning and model-based learning. Both are ways a machine can learn, but the way they think is completely different. So from now on, let's take student A as an instance-based learner and student B as a model-based learner. We will see how each one learns and makes decisions. Let's start with the student A, the one who memorizes everything. That's how instant-based learning works. It is also called as lazy learning or memory-based learning. Instead of creating a separate model, it just stores all the example it has seen. So here I have provided an example with a graph. For an instance-based learning, every triangles and squares have represents the training data. The red X is a new data point, a new instance that we need to predict. So what's happened here is the algorithms looks around and check which points are closest to it. The most of the nearest neighbors here are triangle. So it predicts this new instance also as a triangle. That's how algorithms like K nearest neighbors also works. They don't need to build formulas. They just compare and design based on the similarities. To keep instance-based learning simple, I have summarized it using bullet points. So it memorized data. It used similarity to predict. The example for an instance-based learning is KNN. Now let's talk about the smart student B, our model-based learner. This one doesn't memorize. This learner doesn't memorize everything. Instead, he tries to understand the pattern behind what he learns. In model-based learning, the system builds a mathematical model. Think of it this way. If I x is the input, the model learns the function f of x that gives the output. For an example, f of x is equal to 2x means the system has figured out that the output is just twice the input. So instead of searching throughout an old example like instant-based learning, it now uses this learned function f of x to make the prediction directly. Now look at this visual. We have triangles and squares as a part of our training data. But this time the model has drawn a decision boundary, the dotted line, right? It separates one class from another class when a new data point comes in. In this example itself, you can able to see an X new instance red cross, right? The model doesn't compare it with every examples, like it does not looking for a similar kind of data points to make a prediction. Instead, it simply checks which side of the boundary it falls on and predict the class. Now it falls under the boundary of triangle, so it will predict this as a triangle. That this is how the algorithms like linear regression, logistic regression, random forest do. They focus on finding the underlying structure in the class. So to keep in short, it learns rules and structure from the data. It gives faster prediction once the data got trained, and it's generalized much better to predict unseen data. Let's quickly compare the two approaches side by side: instant-based and model-based. Instant-based memorize data, slow to predict, weak on new data. The example for instant-based learning is KNN. Model-based learning. Model-based learning learns patterns, fast to predict, strong on new data. Example for model-based learning is regression and random forest. So basically, instant-based learning is like the students who memorize. The model is very simple but not scalable. Model-based learning is like the student who truly understands, smarter and more adaptable. In short, one learns from the example, the other learns from the experience. And together, they explain two of the most important way machine learns. Thank you.